Right, now you already know that if y equals sine theta, dy by d theta is cos theta. But in this video we're going to prove this from first principles. So, y equals sine theta, and what we're going to do is we're going to increase y by a very small amount. And we're going to call that very small amount delta y. So, if y is sine theta, then y plus delta y is sine of theta plus delta theta. Now we know from the compound angle formulae that sine theta plus delta theta is sine theta cos delta theta plus cos theta sine delta theta. So let's now take y from each side. So delta y is sine theta cos delta theta plus cos theta sine delta theta minus y, but y is sine theta. And now I'm going to make sine theta a factor of the first term and the last term, and obviously that still leaves cos theta sine delta theta. Now I'm going to divide both sides by delta theta, so I've now got that expression there. And then, as with other stuff we've done on differentiating from first principles, I'm going to let delta theta tend to nothing. So delta y divided by delta theta is going to become the actual gradient at that point, dy by d theta. But remember that delta y divided by delta theta equals this expression. So let's think about this part here. I've got sine theta divided by delta theta, and this is when delta theta is very small. And we've done some work on small angles already, and we know that if theta is small, then sine theta is approximately equal to theta. Well, theta is small in this case. We've called it delta theta. It's a small increase in the angle. So theta is small, so sine theta over delta theta is simply equal to 1. We also know that if theta is small, then, let's get the pen going, cos theta is approximately 1 minus theta squared over 2. 1 minus theta squared over 2. So we've got sine delta theta and delta theta being approximately equal. That's what this is saying. So I can replace sine delta theta and delta theta by 1. And cos delta theta, remember we've got delta theta is small, this only works if delta theta is small. So cos delta theta is going to be 1 minus delta theta squared over 2. So this is going to become 1 minus delta theta squared over 2 minus 1. That's obviously going to be equal to minus delta theta squared over 2. So this over that can be replaced by this part in here. So let's write this out neatly on the next slide. So we're now going to write that dy by d theta is the limit, as delta theta tends to 0, of sine theta times minus delta theta squared over 2 plus cos theta. But if delta theta is tending to 0, then that's 0, 0 times 0 is 0, so the limit of this whole expression is simply cos theta. And there's our proof.